Air pollution, Cambridge IGCSE chemistry. So we'll start with a review of the composition of dry air, look at carbon-based air pollutants, acidic oxide pollutants, and then the idea of greenhouse gases. So a quick review of the composition of dry air. What gas and what is the percentage composition for the blue portion, the orange portion, and the green portion? Speak it out or write it down. Come back to check and correct when you are ready. Okay, so oxygen is at 21%, nitrogen at 78%, and other gases are 1%. Those other gases are mostly carbon dioxide and argon. Let's review the carbon-based pollutants. So these are mainly produced by the combustion of fossil fuels like petrol or natural gas, and that generates or leads to the release of a number of carbon-based air pollutants. Now, fossil fuel combustion can either be complete or incomplete. There are three potential pollutant products. Do you recall them? Okay, well, I'm going to reveal the first. The complete combustion leads to carbon dioxide. Incomplete combustion leads to carbon monoxide and also carbon particulates. Carbon monoxide is toxic and causes direct harm if inhaled. Carbon particulates, they are carcinogens, that is, they induce or cause cancers. Carbon dioxide is, of course, a greenhouse gas. But what other carbon greenhouse gas is released into the atmosphere by human activity? It's methane. But where does methane released by human activity come from? What is the human activity involved? That, of course, is farming, more specifically dairy farming. Cows, through the process of digestion, produce methane. Plant decomposition produces methane. Methane and carbon dioxide are greenhouse gases. What is the problem caused by greenhouse gases? Okay, so greenhouse gases lead to global warming. What's the problem with global warming? Global warming produces climate change. The four pollutants, carbon-based pollutants mentioned on the previous slide, all have chemical formulae to represent them and can be represented in simple atomic scale models or diagrams. Could you identify, draw a line or identify each representation with the correct name, and can you write its formula? Pause, complete that task, come back to check and correct. Okay, so methane, obviously 1 carbon, 4 hydrogens. The carbon particulates, 1 type of atom. Carbon monoxide, so 1-to-1 ratio between carbon and oxygen. Carbon dioxide, a 1-to-2 ratio. So the formulae, CH4 for methane, you must know that. Carbon dioxide, carbon monoxide, carbon particulates are represented just by capital C, the symbol for carbon. So let's move on to the acidic oxide pollutant gases, SO2 and NOx. These are released into the atmosphere on the combustion of fossil fuels. Let's start with SO2. Can you name SO2? Where does the element sulfur come from? What is the equation for the formation of SO2? What's the effect of water vapor and air on SO2? And what is the environmental impact? Pause. Try and complete as much of this table about SO2 as possible. Okay, so SO2 is, of course, sulfur dioxide. Where does the element sulfur come from? It's an impurity in the fossil fuel. So fossil fuels contain sulfur as an impurity. They are products of animal proteins or plant proteins which contain sulfur. So when a fossil fuel is combusted, the sulfur is also combusted to make sulfur dioxide. That sulfur dioxide is released into the atmosphere to meet water vapor and air. It forms dilute sulfuric acid. Now, the environmental impact is that dilute sulfuric acid falls as acid rain, which harms trees and aquatic life and damages limestone buildings. Let's move on to NOx. NOx gases, nitrogen oxides. Where does the element nitrogen come from? Is there a formation equation? What's the effect of water vapor and air on NOx gases, and what are the environmental impacts? Pause, see what you can answer, come back to check and correct. Okay, so NOx gases, the element nitrogen comes from the air. So how is it formed? NOx gases, how are they formed from nitrogen and oxygen from the air? Well, straightforward reaction, but only in very hot engines. In the classroom, nitrogen and oxygen do not react, but in a very hot car engine, for example, they do, to form a variety of oxides. Hence, the number X is not specified. It could be 1-to-1 ratio, could be 1-to-2, could be 2-to-1, could be 2-to-3, etc. So they are collectively known as NOx gases, nitrogen oxides. The effect of water vapor and air is to form dilute nitric acid, which of course falls as acid rain. So it's a contributor to the acid rain problem. But NOx gases also at street level cause harmful photochemical smog, which has its own direct harmful effects on human health. It's not all doom and gloom. There are solutions to these environmental problems. Here are 7 solutions. Here are the 3 problems: global warming, acid rain, smog, and breathing difficulties caused by that photochemical smog. Allocate the solution to the problem. Take your time, think it through, come back to check and correct when you are ready. Okay, so I hope you've made an attempt. If you add a catalytic converter to vehicle exhausts, that will reduce the NOx gas emissions, for example, and therefore smog and breathing difficulties will be reduced. Global warming, well, is caused by carbon dioxide from the burning of fossil fuels. If we can power cars in a different way with a hydrogen-oxygen fuel cell, that would save on carbon dioxide emissions. Well, we could also absorb some carbon dioxide from the atmosphere by planting and growing more trees. Acid rain, if we remove sulfur from the flue, the chimneys in or at power stations, then that would reduce the emission of sulfur dioxide into the atmosphere, and that would reduce the acid rain problem. And that has been done to a very great extent in Europe. If we eat more plants and less meat, that would lead to less dairy farming and less methane released. Methane is, if you recall, a greenhouse gas. If you look in a UK petrol station, you will see that all the fuels are low sulfur fuels. That will reduce the emission of sulfur dioxide and hence alleviate or reduce the acid rain problem. And of course, well known, no doubt, if you use wind and solar power, that is renewable energy, that will reduce the reliance on fossil fuels for energy and hence less carbon dioxide emissions and less global warming. Here's a summary of those discussions from the previous slide, just in case you didn't get a chance to take a proper note. Pause and make sure your notes are complete. A simple explanation for the action of greenhouse gases. Certain wavelengths of thermal energy are absorbed by certain covalent bonds, and they cause the covalent bond to vibrate. So thermal energy comes in of a certain wavelength, and the bond vibrates, absorbing that energy. And this leads to the greenhouse effect. So the Earth's surface absorbs energy from the sun. So the purple arrow is light and ultraviolet energy from the sun passing through the atmosphere and reaching the Earth's surface. Now the Earth's surface re-emits the energy, the red arrows, as thermal energy, that is heat. Some of that energy is absorbed by greenhouse gases, carbon dioxide and methane. Only some of that energy escapes into space. These are the bonds most associated with the absorption of thermal energy, not required at GCSE. However, some of the thermal energy is absorbed, and that reduces the amount escaping into space. You are expected at GCSE to explain the link between human activity and global warming. So there are two principal human activities associated or that need to be taken into account: the burning of fossil fuels to generate energy and dairy farming, which releases waste gases. What two steps are needed to then explain increased global temperatures? So there are two logical steps between the human activity and the increasing global temperatures. Have a go and make two statements that will fit the logical steps. Pause, come back to check and correct when you have attempted it. Okay, so to reveal, fossil fuels and dairy farming, fossil fuel combustion, lead to increased levels of carbon dioxide and methane in the atmosphere. The next logical step is that leads to an increased absorption of thermal energy and therefore increased global temperatures. So the link between human activity and global warming is through increased levels of carbon dioxide, and methane, which are greenhouse gases. So there's an increase in the absorption of thermal energy, and that leads to global temperatures. Can you recall a couple of solutions to the global warming problem? Pause, speak out or write down your solutions, then come back to check and correct. Okay, so the first obvious solution is to use alternative energy sources, for instance, wind power. So that would reduce the combustion of fossil fuels. We could also, not mentioned so far in this lesson, reduce energy use by, for instance, insulating home. If we reduce energy use, less fossil fuels would be needed to be combusted. There are other solutions, of course. As this topic is knowledge-based, I would recommend that you go through the lesson again, making sure that you answer the questions either by speaking them out or by writing them down, and then back that up with some past paper question work, but make sure it's for the correct specification. Thanks for watching. I hope you've learnt some chemistry. Please subscribe and please like.